So that's good. Hey guys, could you all comment so I can do register? At the moment I got Tom and Ed. Yeah. Right, so got Molly, Jack, and Jasmine. Grace. Anybody else here yet? And Jake. Cool. All right, so we're going to start off with this one today, which is a first year integration question. So the idea for today is to look at area integrals. So we're going to start off with an easy one, which is this one from first year. I think we'll do two of these, and then we'll move on to some second year area integrals, and eventually doing parametrics and area between two curves. So this is worth, what was it worth? 10 marks, so I'll give you guys 10 minutes to do it, starting from now. Cool, Ollie, I'll just swipe you in as well. Cool. Cool, Emerald, I've swiped you in as well. Poppy and Rob, I've swapped you guys in as well. Cool. All right, guys. Yeah, I've swiped everyone in who was late. Tried not to be late, but yeah. All right. So, starting with this one. So we need to use calculus to show the turning point is 1. So we differentiate to get dy by dx is 12x squared plus 18x minus 30. Turning points, we're going to make that 0. Then we're going to factorize and solve this. Now all of this is divisible by 6, so we're going to get 2x squared plus, talking about, plus 3x minus 5 equals 0. So factorizes to give us 2x and x. So we want that. So we're going to get x equals minus 5, x equals 8.5. Nope, I've done something wrong. What are we doing? 2 times... What have I done? I can't think today. Gotta be 5 and 1. And we got 10, take... No. Yeah, what have I done? I can't... X coordinate at the turning point. Yeah, make that 0. Yeah, factorize it. We're going to get 2x. Okay, so that has to be minus 1. Oh yeah, what am I talking about? Cool. Sorry, I couldn't see that for a while. So yeah, x is 1, and x is minus 5 over 2. So that's done for the first part. Next bit is do the integral and find the area. Okay, so we know the point there is 1. What we need to do as a plan is we're going to find the area of this integral and add on the area of the triangle AB. So if we do the triangle first quickly, we know the x-coordinate here is 1. We can solve for where this crosses. So if I get out the calculator, we're going to solve that cubic. So I type it all in: 4, 9, minus 30, and 8. Minus 8 even. And we get x is going to be 2 there. So that gives me a base of 1 on this triangle. If I put my x coordinate in, I can find my y coordinate. So we get 4 plus 9, take 30, take 8. Gives you minus 25. So the area of the triangle is going to be half of 25, which is 12.5. Right, so that's the area of the triangle. All I need to do then is integrate from C. C is the other point across the axis, which I did have, but I think I've now deleted. Yeah. So C is going to be minus... Oh, minus quarter does tell us that. Yeah, cool. Okay, so we're integrating from minus 0.25 up to 1 of that equation, 4x cubed plus 9x squared minus 30x, take 8 dx. So if we do the integral, we're going to get x to the 4 plus 3x cubed minus 15x squared minus 8x from minus a quarter to 1. So I put 1 in and we get 1 plus 3 minus 15, take 8. Take away, put minus a quarter in. And we're going to get 1.012. So 1.02. So I subtract those. 1 plus 3, take 15, take 8, take 1.02. gives you minus 20.02. So let's make that positive because we're talking about an area. So we're going to have 12.5 plus 20.02. So we're going to get 32.52. Cool. There you go. All right, could you guys do some more commenting? Because I don't have any answers from any of you. So make sure you comment for the next one. Next question is this one. So it's another first year integral. Should be pretty straightforward. It's 11 marks. So I'll give you guys 11 minutes. Make sure you comment both your answers for this one. It's 11 minutes starting now. Cool. Yeah, so Grace got the right answer. Good. Let's go through this one then. So use calculus, find the turning points. It's the same question again, really, just slightly different area we need to find. So dy by dx, 8 plus 2x minus 3x squared. Make that equal 0. Solve the quadratic. I'm just going to type it in on the calculator to save some time. So minus 3, 2, and 8. So you get x equals 2. Yeah, there we go. So you'd want to show that as well. We get 3x plus 4, x minus 2, therefore x equals 2 would be a full workings for that one. All right, so we want to work out the area. So we're going to integrate 10 plus 8x plus x squared, take x cubed. And the plan for this one is we're going to integrate to find this area. Then we're going to add on, no we're not, talking rubbish. We're going to integrate all of this and then we're going to subtract the triangle. So we're integrating from 0 to 2. So we get 10x plus 4x squared plus x cubed over 3 minus x to the 4 with our limits of 0 and 2. So that's going to be 10 lots of 2 plus 4 lots of 4 plus 8 over 3 minus 16 over 4. Take away 0. So we get 20 plus 16 plus 8 over 3. Take away 4. We want to try and find an exact area this time, so we need to be a bit careful about it. So I get 32 plus 8 over 3, which is 104 over 3. Now I need to subtract the area of the triangle. So the triangle has a base of 2. Remember, it's half base times height. And if I put 2 in, we get 10 plus 16 plus 4, make 8. 22. So we're going to do 104 over 3, take 22, which gives me 38. 38 over 3. Cool. All right, next one then. So this is one of the, I'm just going to sketch this, and then we've got a parametric integration question. So we want to try and find the area here up to the point K. And we want to do it exactly, so we need to be a little bit careful. Right, so this one is worth 12 marks. I'm going to give you guys 12 minutes. Comment if you need help though, don't just sit there. I know Ollie said waiting for a solution. If you're stuck, ask for some hints and I'll give you hints. So give it a go. Comment when you're got an answer or when you're stuck. Hey guys, please comment a bit more because it's still not really doing much. Yeah, so we want to find k. We know the y coordinate of k is 8. So if we put 8 into there, find theta, put theta into there, we can find x. So 8 equals sec cubed theta. So therefore, sec theta is 2. Therefore, cos theta is a half. So arc cos 0.5 gives me pi by 3. So theta is pi by 3. I can put theta into the x equation to find x. So x equals 3 pi by 3 sine pi by 3. So 3 pi by 3 just turns into pi, and sine pi by 3 is root 3 over 2. So we get root 3 over 2 pi as my x value. Okay, part B, show the area can be in this form. And what we need to use for this one is the fact that to integrate parametrically, you get y dx by the theta. So we need to differentiate x, which we'll do via product rule. So we get 3 sine theta plus 3 theta cos theta using the product rule. We then need to times that by y and simplify everything. So we're going to get integral 3 sine theta plus 3 theta cos theta times by y, which is sec cubed theta d theta. And the integral is from 0 to k being the theta coordinate. So we're going to have pi by 3 there. We also need to check the other coordinate is 0. I've just kind of guessed that. So if we put in x is 0, we get theta is also 0. So x equals 0 leads to theta 0 as well. So if I expand this, we're going to get 3 sine theta over cos cubed theta plus 3 theta cos theta over cos cubed theta. That I can then turn into 3 tan theta over cos squared plus 3 theta over cos squared. So the cos squared on the bottom there, I could take out as a factor and call it sec squared. So let's make some space here. Oh my god. So 3 tan theta sec squared theta plus 3 theta sec squared theta. I can take the 3 outside the integral. And 0 and pi by 3. That is my answer to part B. Okay, last bit, so we actually need to do that integral. Okay, let me write this at the top. So integrating tan theta sec squared theta plus theta sec squared theta from 0 to pi by 3 d theta. Okay, so to do that, first one is quite easy. It's a recognition one. So we got tan differentiates to sec. So we've got fx, f dash x there. So we're going to try tan squared. So that works, but we need to divide it by 2. So we get half tan squared for the first bit. For the second bit, theta times sec squared theta, we need to use by parts. So u equals theta. V dash is sec squared theta. U dash is 1. V is going to be tan theta. So if we put it all together, uv is going to be plus theta tan theta minus the integral of v du dx minus the integral of tan theta. So our final answer is going to be half tan squared theta plus theta and theta minus ln cos, I think, this one. And it is positive, isn't it? Cos differentiate, no, it is negative, so we get plus there. So that's my integral. We need to put in 0, pi by 3. You get the exact value for the area. So we're going to get half tan pi by 3 squared plus pi by 3 tan pi by 3 plus ln cos pi by 3. Take away. Now tan of 0 is 0, cos of 0 is 1, and ln of 1 is 0. So the whole second bracket becomes 0. So to do this, we're going to get, I'll just type in tan pi by 3 do that again. I typed in arctan. Tan pi by 3 is root 3. So we get 3 over 2 for the first term. Plus pi by 3 times root 3. Plus ln cos pi by 3. Which is the half. So we get ln half. Cool. And I don't think we can really simplify that anymore. So that's it. I mean, maybe we could take out a factor of a half. But not really. There's not really much we can do there. Cool. Right. I think that's all that I had in the past paper questions. I wanted to try a pretty horrible couple textbook questions though. So I'm going to start with this one, which is nightmare fuel. Yeah. So I'm going to give you guys 15 minutes to try this, and it's probably going to take us a similar length of time to do this. Take your time with it. It shouldn't be too hard. It might be helpful to color code these, so I'm going to color code the lower graph as green, which is this one, and the upper graph as this one. Remember, area under a graph is what integration finds. So 15 minutes, give it a go, write your answers. We're trying to find an exact value. See what you guys can do in 15 minutes. Right, let's give this a go. So I tried this earlier and it went very badly. So I'm going to try and write a bit neater and go a bit slower this time. So the idea is we want to try and find the 3 points of intersection, and then we're going to integrate to find the area between the curve and the other curve by taking the top curve, basically getting the area from the top curve down and taking away the area from the bottom curve down. So first of all, we're going to integrate both. I think let's do it all separately. So we're going to do, it'll be green take yellow. Take yellow. Here's going to be yellow take green. And then green take yellow again between these limits. First of all, we need to find out what these, what the points of intersection are, what the limits are. So we're going to say sine x plus 2 equals cos 2x plus 2. We can get rid of the 2 from each side. If I change the cos 2x into 1 minus 2 sine squared x, we can get a sine quadratic. So 2 sine squared x plus sine x equals 1. If I solve that, that will find me the points of intersection. So we've got 2 sine x, sine minus 1, we'll take over onto one side. So we get sine x equals a half, and sine x is minus 1. Okay, so solving those two will get me the free roots. So I'm going to need to solve one of these for, if I just sketch sine actually, because we're only solving it from 0 to 3 pi, so we're stopping it here anyway. So sine x equals minus 1, that's easy. We get one solution, which is 3 pi over 2. The other one is a half, which is going to be this solution here and this solution here. So if I do inverse sine of a half, or arcsine, we get pi by 6, which is going to be this value here. And meaning this value is going to be pi take pi by 6, which is going to be 5 pi by 6. So those are my free roots where our equations meet each other. So pi by 6, 5 pi by 6, 3 pi by 2. Cool. Right, so we need to do our integrals. And basically we need to do the integral of, will be the first one, take the second one, then the second one, take the first one take the second one. So I'm going to integrate each bit first of all, and then we're going to chunk it all together at the end. So we're going to integrate sine x, a little bit smaller, sine x plus 2, and I'm going to integrate cos x, cos 2x plus 2. So the integral of sine integrates to minus cos, and the 2 is going to go to 2x. For the other one, for cos 2x, cos integrates to sine, but we need to have a half out the front, so you get a half sine 2x plus 2x. So those are my two actual integral functions. All we need to do for the rest of this is put in some limits. Right, so we're going to have let's write this all out in a massive line, because I think some of this is going to cancel. So we're going to get the green one, which is the cos integral. I should have done these in green and yellow. Let's just put a blob next to it. So that's the green one. That's the yellow one. So for the first bit, let's call it part 1, 2, and 3. For part 1, it's going to be the green one, from 0 to pi by 6, take away the yellow one from 0 to pi by 6. So you get that. Take away the 0 root. So it's gonna turn into 0. So I'm gonna just write minus 0 there. So from that, I need to take away the yellow one. So I need to do take away. Let's do it on a different line. Take away. Oh, have I done it in the wrong place already? No, we're good. Take away minus cos pi by 6 plus 2 pi by 6, second bracket. Take away minus cos 0. The other bit's going to go to 0 anyway. So we get that for my first bit. Onto that, so if I put that as a red minus because that applies to both brackets, we're now going to add the yellow one from 5 pi by 6, take away the green one, pi by 6 to pi by 6. So we're going to add onto this yellow, that because minus cos 5 pi by 6 plus 2 lots. Let's just call it 10 pi by 6. Take away the thing that we already have. Wondering if this is going to cancel. So we got that minus that plus this minus that same thing. Is there an easy way to do this? Let's get rid of that 0 for a start. So let's write it out, and in the end we'll expand all the brackets, and hopefully we'll get some stuff cancelling. So take away. So this really no. This is part 2. That's part 1. This is part 2. So take away minus cos pi by 6 plus 2 pi by 6. There's that bit, and then that needs to have taken away from it. Here. The green one, half sine of 2 lots of 5 pi by 6, so 10 pi by 6 plus 10 pi by 6. Oops. And that needs to subtract what we had before, half sine 2 pi by 6 plus 2 pi by 6. Oh dear, alright, that's the first one. Alright, I'll write out the last one, and then I think I'm going to try and simplify it all at the top. And this should all work. So onto that we're going to add yep. The green one. God, I'm definitely going to run out of room. So we're going to add half sine 3 pi plus 3 pi. Take away half sine 10 pi by 6 plus 10 by 6. Take away yellow one, which is minus cos 3 pi by 2 plus 3 pi. Take the bit we did before, minus cos 5 pi by 6 plus 10 by 6. Right, so that should work. I'm going to delete the picture, get rid of this, so that we've just got this massive equation. I'm hoping some of it's going to simplify, because typing this into the calculator will take at least 5 minutes, and we're running out of time. So, alright, I'm going to simplify this as much as I can on the way. So I'm going to get rid of all this like in-between signs. I just have terms now. So we got half sine pi by 3 plus pi by 3. So we now got minus, minus. So we're going to get plus cos pi by 6. Minus and plus is going to be minus pi by 3. Then we've got minus, 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 which overall is going to be a minus cos of 0. So that's minus 1. On to the next line. So I've done all of that bit. I'm going to delete it as I go. So if I do make a mistake, it's too late then. Plus nope, it's going to be negative. So take cos 5 pi by 6. Take 5 over 3 pi. Nope, that should be plus. I made a sign error there. Good. So plus cos pi by 6. Take pi by 3. Next bit, minus half sine 5 pi by 3. Take 5 pi by 3. Minus minus is plus half sine pi by 3 plus pi by 3. So that is all this bit as well. I'm sure there's an easy way to do this. All right, plus half sine 3 pi plus 3 pi. Take half sine 5 pi by 3. Take 5 pi by 3 plus cos 3 pi over 2. Take 3 pi minus cos 5 pi by 6 plus 5 pi by 3. Okay, so if we go through this, hopefully there's some stuff that I can just cross out because we've added it and subtracted it. All right, so I can see. God, what can I see? There's a 5 pi by 3. There's a minus 5 pi by 3, so they're gone. Plus 3 pi minus 3 pi, so they're gone. Back at the top, we've got, not easy to see. There's minus pi by 3, plus pi by 3, so those are gone. I might just erase these. Becoming clearer. We've got plus pi by 3 and minus pi by 3, so those can go. Is there anything else you guys can see that cancels? Oh yeah, pi by 3, minus pi by 3 there. No, the rest doesn't cancel. But we can kind of simplify it. So we got half sine pi by 3 there. There's another half sine pi by 3 there, so that's going to be sine pi by 3. Cos pi by 6, another cos pi by 6, so there and there, so that's going to be plus 2 cos pi by 6. We've got a 2 halves there, so that makes minus sine 5 pi by 3. We've got minus 2 of those, so minus 2 cos 5 pi by 6. And then what's left, we've got plus half sine 3 pi plus cos 3 pi by 2. That's that one and that one. And then there's a minus 1 at the end. So if I type all that in, that's as simple as I can make it. We'll see what we get. Hopefully it's positive, because definitely should be a positive area here. And we've got 2 minutes for me to type this in. And minus 1. I got positive, that's good. I got exactly minus 1 plus 3 root 3, which is 4.196. Cool. Right, that's going to be it for today. We don't have a lecture on Friday, so we're going to do a bit more integration next week, and then probably vectors next week as well. If you guys would like to try that one at home on a big sheet of paper, see if you can work out, see if you can get the same answer, let me know next week. Otherwise, guys, have a nice 3-day weekend, and I'll see you next Tuesday for you guys. Cheers. Bye.